Okay, so what rule have you guys been utilizing so far? What was that? Crisscross rule, right? So I know you're looking at your sheets because these polyatomics are weird and they've got interesting charges and combination of elements. So I know you're gonna look at your sheets for a little while. Who's already gone through 1 through 4? Okay, seeing where we are. All right, so let's run through the first 3 together, and then I'm going to address how to deal with this cobalt 2 hydroxide. All right, so everybody up here with me, okay? So what is calcium's charge, guys? 2 plus, and you definitely need a periodic table out, okay? So go ahead and grab one just so you're not always looking up at the wall, because if that fell down and totally ripped, we wouldn't know what to do. Okay. All right, so calcium got 2 plus. What is oxalate's charge? Or what is oxalate? C2O4 what? 2 minus. Okay, so let me tell you a tip here. We have a couple of different endings, and these endings, that you've started to hear them and see them a lot. So what are some of those suffixes that you've been seeing? Suffixes on the very end. 8. Okay, keep going. Ite and ide, right? Okay, so I'd rather use the periodic table for everything, right? Because I always have the periodic table. I can get charges from the periodic table. There's no secrets in the periodic table. Ides means that both come from PTOE. That means like both ions or both elements or both atoms, okay? Both come from PTOE, like sodium chloride, lithium oxide, magnesium nitride, anything with an I ending. There is one caveat though. Look on your polyatomic ion list. Who has I? Cyanide and hydroxide. So cyanide and hydroxide are the only 2 exceptions to this rule. Every other ide ending means that those 2 elements came from the PTOE, and you just crisscross their charges. Okay? So cyanide, Cn1 minus, and hydroxide, OH1 minus, are the only 2 that they're kind of sneaky and they're in the I. So, if that I means that all that came from the periodic table, there's no polyatomics involved, what does this mean? 8 ending with an 8 and ending with an ite. That means they are polyatomics. And where would you find the polyatomics if you didn't have your list? No, if you didn't have your list. Up here. It's got to be up here, okay? And I just hate it. Eight, right? When I have to use the polys, because it means I have to memorize them and I have to use my brain, okay? So I'd rather use the periodic table. 8s and ites means that you're using your polyatomic ion list. But not for very long, because soon they will be memorized, okay? Okay, so far we've got 8. Number 2 is an 8. Number 3 is an ite. So 8, ite, those are all 3 these all 3 contain what at the end? Polyatomic ions as they bond to make their overall compound. So that's how we needed to use. We saw the 8, we look and we're like, I don't know what oxalate is. I look on my polyatomic ion list. That's oxalate. When I crisscross those charges, I get 2 2s, right? Now, if I write Ca2, parentheses C2O4, parentheses 2, what's the ratio I see? Okay, so I see a 1-to-1, right? But I see initially I see a 2-to-2 ratio, but then I go, okay, that's really that can be simplified, so I will. So I call that Ca parentheses C2O4 parentheses. What did I not write here? The ones because they're stupid. Okay, aluminum permanganate. Aluminum. Al3 plus because it's in group 3. Permanganate is not an element. What is it?
MnO4.
MnO4. I'm going to put parentheses on that, right? Poly parentheses, 1 minus. Crisscross that. What do you get, Manav?
I got Al parentheses and then O4.
Beautiful. Okay? So there's our first one. There's our second one. Okay? Sodium bisulfite. Sodium, guys? Na plus. I got Hannah on par. Can somebody else help her out? Okay. Na plus, and then bisulfite. So 3, right? HSO. So bisulfate is SO4. Bisulfite is SO3, right? You guys, and those are really, they're nuanced. So you have to watch their ites and eights. And that's a 1 minus, right? Okay, so when I crisscross a 1 and a 1 down, they don't appear, right? Because they're ugly. We lose them. And so we get NA, parentheses, H, parentheses, 1. Okay, so far so good. Those are compounds that involve polyatomic ions. Now, we're going to bounce around to some others that utilize the periodic table more. But before I do that, I need to tell you what to do with this cobalt, with the Roman numeral 2. Okay? Can I go back? Can I go back some slides? I'm good? Okay. So hold on to your papers for a moment, because this is, okay. So this is going to be like notes, so pick back up where you left off yesterday. Just so you have everything kind of in the same place. You're not too frazzled. I'm not reviewing how to get the charges from the periodic table. Give me a thumbs up if you can find the charges from the periodic table. We've been doing this for 2 weeks. Everybody in group 1 gets A. +1. Everybody in group 2 gets A. Everybody in group 3. Everybody in group 4. Plus or minus 4 depends on the situation. I will tell you the situation now since I keep saying that. If it's a cation, because it's listed first, like in a compound, you write the cation first and then the anion second. If it's listed first, it's a cation, meaning you put it as a positive charge. And if it's an anion, that means it's listed second, and you give it a negative charge. So I could give you like sodium carbide. Carbide sounds like what element? Carbon. So that means you're going to give it a C4 minus because it's listed second in the compound. So what I just used as an example was sodium carbide. So that's sodium with a charge of what? +1. And this is carbon with a charge of, why not +4? It's got to be the anion because this is the cation because it's positively charged. You can't put 2 cations together. It's 21st century, I know, but it's just not how it works. So then you put C4 minus and crisscross that. What do you get? C1, right? But we don't even write the 1. So that's the scenario for the plus and minus 4. Group 5? -3. Group 6? 7? 8? 0. None. Okay. So that's a quick review of charges. And then now, we've been skipping this big chunk in the middle of the periodic table, right? This whole time. Called the transition metals. The reason they're called transition is because they have transitional charges. Okay? They have variability in their charge. So just like we just reviewed, everybody in group 1 always gets +1. No variability there, right? Everybody in group 7 always gets a -1. No variability. Well, now if I have variability, I have to have a system to communicate the charge. So the system is what I'm going to show you here. So they have many charges. So the most common transition metals that we utilize that have these various charges are copper, iron, magnesium, or mercury, lead, tin, chromium, and then manganese, cobalt. Literally, I can give you the whole entire block of transition metals, but these are very common for us to use. So what we utilize to indicate, hey, I'm a +2 charge or I'm a +3 charge, we use Roman numerals. That was the example question on question 5. Okay, so the system, we term this Roman numeral system, we call it a stock system. I'll let you write down some of that first, and then we'll talk about how this works. So a Roman numeral is the way that I will communicate to you and you will communicate to me the charge of a transition metal. So I know tin, well tin is Sn, And SN is a transition metal. Now, can you guys find the periodic table first for me? Is it actually in the transition metal block? No, it's past it, right? So it's in group 4. So that's actually called a post-transition metal, but it still acts transition as a transition. So we're going to kind of keep that in the same category. So tin symbol is SN. So since it's a transition metal, we don't know the charge of it for sure. So I have to indicate that to you. The Roman numeral is always behind the symbol or behind the name, so it's referring to the charge of tin. So now you know, don't have to look at the periodic table. Tin's charge is what? 2, and that's going to be 2 plus because remember cations come first. And then chloride is what? Cl is chlorine, right? And what's the charge of chlorine? 1 minus. And when you crisscross those charges, what do you get? Beautiful. And that is called, so we're saying it out loud as SnCl2, but we call it tin 2 chloride. So you can't just say tin chloride, because I'm going to say tin what? Like, what's the charge? Because tin doesn't have a distinguished charge, so we have to communicate that orally as well. So what is this called? Tin 2 chloride. This is called? Lead 4 what? Sulfide, right? So what do these I's indicate to you? Those are elements straight from PTOE, right? So what's lead's charge? So what's lead symbol? Pb. Okay, so that's lead symbol is a 4 plus charge because this is referring to the charge of lead. Sulfide is what? Sulfur with a charge of -2. Crisscross, what do you get? Pb2 S4. And you're like, huh, what's my ratio? 1 to 2. So this is simple. You can simplify this. So if you can simplify, you should, because for every 1 lead, you only need 2 sulfurs. So you need not a 2 to 4 ratio, you need a 1 to 2, so that would be PbS2. So this is the better answer. This one is not simplified. We okay so far? Transition metals, okay. So the other one, so this one's way important. This one is more important than this classical system here. The stock system just means like in the stock room, like I have a whole stock room of chemicals, everything that you guys would need for labs. So that's what, like how we label them in the stock room. Way back before we had stock rooms and chemicals were just stored on a shelf next to your flour, they call things a little differently, and that's called the classical system. So they use phrases like os and like ferrous or ferric to indicate the actual charge that they're working with. So take a second here. So when you see the ferrous, ferric, there is a symbol in the periodic table that kind of looks like that. Who is it? Iron. So we call it iron now, but they didn't call it iron then, which is why it came to be that symbol. Fe is a symbol for iron. Fe and iron don't really look like they have anything in common, but it's because back in the day they named it after what they called it, which was ferrous. So the 2 possible charges for iron 2 plus and iron 3 plus. Those are the 2 most common possible charges for iron. So who is the smaller of the cations? Say again? Sorry, which charge is the smaller of the cations? 2 plus, right? So this would be the one that we have with the os. And then who's the higher of the cations? The 3 plus, so that's the one that will end with ic. So I always remember os is low, os is low, os low. Ic kind of sounds like you're going ick, like you have a high pitch, so it's higher. Yeah, like a hic. I don't know. So that's how I've always remembered. Os is the lower charge, and ick is the higher charge, just because of the inflection of my voice. So when I name out or write out ferrous chloride, ferrous is referring to who again? Fe what? Fe2 plus, and chloride is who? Fluorine with a 1 charge crisscross, what do you get? Cl2. And we would call that out. Give me both names for it. Ferrous chloride, or in our more traditional way, iron 2 chloride. So that 2 is referring to the charge that we crisscrossed from iron. Okay? All right, so we don't see this very often, but if you do see it, don't be afraid. You can do it. Okay? All right, so let's go back to the ones we were just working with. Oh, I have to tell you one more thing with transitions. There are some so I will always tell you the charges of transition via Roman numeral. There are some that don't have any variation. Therefore, they have a single charge. So if everybody knows that single charge they take, do we need to write a Roman numeral? No, if it always has one charge and there's no question about what its charge should be, we don't need to write the Roman numeral for that one. There are 3 that do that. Zinc always gets a 2+ charge. Always. So one would never say zinc 2, like zinc 2 chloride. We'd never say that because it always has a 2, so there's no question in our mind. Silver always gets a +1. And cadmium, there it is, cadmium always gets +2. So these will be memorized because there will be no indication on the periodic table what the charge is, so you have to know what it is, and when I say it, I know what it is. We're communicating on the same wavelength here. The way I remember them is Z kind of looks like a 2, right? So that helps me out there. Z kind of looks like a 2, so zinc always gets 2+ charge. In my book, silver's number 1. Okay, do that with me. Silver's number 1. Okay, you're going to think it's just doofusy, but you will remember this. Silver's number 1. So if I do this again, you'll remember silver is always going to have a +1 charge. And then where's cadmium in relationship to zinc? Right underneath it. So let's kind of call that a tip, right? That's a tip to tell you if zinc is a 2+, cadmium is also a 2+. Okay? All right, so do we write Roman numerals for these? No, because they always have the same charge. Okay. All right, so here, let's get down to 5. Cobalt 2 hydroxide. Start there. And then you guys can go through, let me make sure I want to do all these. I'm going to circle the ones on the board I want you to do right now, okay? So do 5, 7, 8, 9, 12. Start there. 5, 7, 8, 9, 12. You guys are just beginning our language. I totally recommend writing the ions, the charges, and crisscrossing. So like don't always do it in pen, so you get pretty good at it. So do try to work through your process so you don't end up getting these wrong.
Most time I take on the periodic table, hydroxide is one of those ones that's not.
Right, what number are you guys on? Okay, if you're done, check on the board. You can get ahead a little bit on another part here. I'm just going to have everybody try to catch up so we're all on the same page. All right, so check on the board for me now. We have COOH2. So that kind of pause is just me saying parentheses. Do remember hydroxide sounds like it's, so like when in order the way it's written, hydro kind of sounds like what element? Hydrogen, and oxygen or oxide sounds like oxygen. We don't write ho, we write O. Okay, please remember that. Okay, so that we're not disrespecting hydroxide. Nitride, ides, nitrogen. Fluoride, fluoride is fluorine. Oxide is oxygen. Those are all straight from PTOE, no polys involved. This was that one with the chromium 3, so we end up crisscrossing the 3 charge over. And then acetate, did I do this with you yesterday? Acetate.
Yes.
Okay, so that's the one with 3 letters, C2H3O2, and the barium's charge gets crisscrossed over. Okay, so now that we feel okay with crisscrossing charges, all we've done so far is take name to formula. What else do you think we need to do?
Formula to name.
Formula to name. Right. Question.
Aluminum fluoride.
Aluminum fluoride. AlF3.
Yeah, those failed too.
So aluminum has a 3+ charge because it's in group 3. Fluorine is in group 7, and it's in group 7, so it gains 1 electron to look like an octet, so it gets a -1. Good? You're good. I know a lot of people, because they're like, oh, it's 1 away, but it's 1 away. All right, so let's go to naming, or from formulas to names. So don't forget you're on your PTOE, on your polys, you got to start memorizing them, so that's one of those flashcard moments. I want to give you some tips though before I move away from that. If you'd like to write this on your poly sheet, that's fine. So we have there's a pattern in these polyatomic ions. Now, every little clump of polys are different. So like sulfate's different than phosphate, different from nitrate, different from acetate. But this is your kind of cheat sheet. Okay, so I'm gonna do an example with this so that all these little tips make sense. So everybody look at chlorate for me. Look at chlorate. Work with me on my example before you start just writing just mindlessly, okay? What's chlorate? ClO what? ClO3 1-, right? Okay, so this is chlorate. So chlorate is the one you should memorize. All the 8s you should memorize, because if you know the pattern, you know how to modify from 8 to ite. Then you don't have to memorize the ites. It's just going to follow the pattern. So everybody look at chlorite. What's chlorite? 2 1-, right? So from chlorate, we went from a 3 to chlorite. We have a 2 on the oxygen. So what do we do to oxygen? We subtracted 1. So if I go from 8 to ite, I just subtract 1 oxygen. That's it. Okay, so if you know all your 8s, you automatically know all your ites for that particular version. Now, there are some that can take on more oxygens and even lesser oxygens than we have here, and that's where the hypo and the per come in. Everybody look at hypochlorite on your sheet. Hypochlorite? ClO. So that's a 1 on the oxygen, right? So we know this prefix hypo. We've maybe heard it before. Where have we heard it before? Hypoallergenic. So it's a dog that has lower or gives off lower pet dander, so your allergies don't act up as much. So it means that you have a diminished effect. Or hypodermic needle. Where does it go? Under your skin, right? So hypo means under. So it's 1 under where we are. So ite has 2 oxygens. Hypo goes 1 less, so that's 1 oxygen. So this is hypochlorite. And then per, it's kind of, we don't use it all the time, but per in everyday language should mean +1, so 1 more or ahead or more kind of thing. So per is the other prefix. Look on there. Do you guys have perchlorate?
Yeah.
What is it? ClO4, 1 minus. So it's per, 1 more, per chlor 8, and that's from the 8 version. So 8, you memorize. Ites, you already know because they're what?
1 less.
1 less. Hypoites, you already know because they're
2 less.
2 less. And then pers, you already know 1 more. Okay? The other ones don't really have a trend or anything. I already told you about the ides. Most of the ides are from PTOE, but these are just the 2 random polys that have ides. There's ammonium, which is just really weird in how it's supposed to be relating to you what its formula is. What is ammonium's formula? NH4 plus, right. So that does not have an 8, an ite, an ide. It's got an eum. So it's just one of those random ones that you'll just have to fit into your memory in some way or form. The prefix, just get this out of the way. The prefix bi does not mean 2 for polys. The prefix bi means to add an H plus in the front. So everybody look at sulfate for me. Sulfate. What is the formula? SO4, 2 minus, right? And then we go and we just add a little bi on the front. So that's bisulfate. And essentially what we're doing is 2 sulfate, we're adding an H plus, and we're mushing them together. So we have sulfate, and then we are going to add it with an H plus, and so the H is going to go in the front, so we're going to write HSO4, but then what is a -2 and a +1, what do they add up to? Say again? -1, and that's the charge on bisulfate. So if you know bi means to add an H plus, and you already know the 8 version of it, you add an H plus and you modify it. You okay? Alright, so those are your tips for you on memorization. Alright, now let's take this and actually write the formula names out. Okay, so you guys already know how to do this. You've actually seen these a lot. So but this is kind of like just the notes I had to help you with this. So if we have an ionic compound, you take the cation, you don't change the name. This is magnesium, this is magnesium. We call it magnesium, right? So when you have a cation, you name it like you normally name it. So let me give you an example. What's the first one on the other side of the columns? What's it say? Oh, that's okay. So let me look at the sheet because I don't want to do a poly just yet. And I'm going to go like this. Okay, so example, it's the third one down, CaO. Okay, so we recognize there are 2 pieces to this. This is the first piece. This is the second piece. Well, that's actually what? Calcium. Notice it's calcium 2 plus in actuality because it's, the charge is the ion. But we just try to call it normally calcium. We don't call that oxygen, right? We call it oxide. So we always take I don't have that on here. It's on the next slide. We take the second name. So we take the anion and we drop the ending and we add "ide." So fluorine would be what? Fluoride. Sulfur would be sulfide. Nitrogen would be nitride. Phosphorus would be phosphide, and so forth. Okay? Now, transition metals, we take the name just like it is. We don't change the first name. We change the second name to "ide." Now, what has a poly on the end? What's the ending? Ate or ite or ide. EM's going to be something different, okay? Or ide. So those are a couple of different ones we can have there. Okay, so we just named this one calcium oxide. Okay, let's go down to 5. Okay, you're writing these names out on your paper with me. Break it into 2 parts. First name, last name. Potassium. And then the last name is bromide. Okay. Notice on my polys 1 through 10 or whatever, notice I don't have parentheses on all of them, right? And that's just because if there's not a subscript other than 1, you don't absolutely have to put the parentheses for it to be correct, but I believe it helps you a whole lot to write the parentheses. So I want to start with the first two because they have parentheses, and then we'll kind of knock out the parentheses in the next. So there are always going to be a first name, last name. If you start saying like nitrogen, hydrogen, sulfur oxide, that's like a 4-person name or four name compound. That is totally wrong. If it sounds ugly, it's wrong. Okay. So we want to break this into 2 pieces. What are the 2 pieces here? So you see the parentheses, right? This is a polyatomic ion. It's the only cation that we really deal with. So block this off. That's the first name. And then all this junk at the back is the last name. So now we should start to see, what is NH4? Ammonium. It's the only cation of the polyatomic ion list. Okay? Then we see SO4. Well, who does that look like? So it's not sulfide, because that's not, SO4 itself is not found on the periodic table. It is sulfate. So first of all, you recognize this as a poly, and then you've got a 50-50 chance of getting this right. If you don't remember SO4, you're like, is it sulfate or is it sulfite? Who is it? Sulfate. And where is this 2 right here coming from? The crisscross from sulfate. So that formed because we took ammonium with its +1 charge, and we took sulfate with its 2 negative charge, and we crisscrossed their charges. That's how we formed that compound. All right, the next one, break it into 2 parts. First name, calcium. Big thing on the back side is not an element, it's a poly. So give me your best guess without looking at your sheet. Phosphate. You could have said phosphate or phosphite because you're starting to get your memorization underway, but that is definitely phosphate. Calcium, phosphate. Okay. Thumbs up if I can go down. I like it when you participate in my surveys. Okay, so now number 4, again, 2 names. Break it off. Who's going to be the first name? Lithium. So lithium is a metal. It's a cation. It's going to be perfect. We're going to just name it like it is, lithium. Who's this big hunk on the back? Who is it? Carbonate. So you see carbon, but you know it can't be carbide because that would be a simple carbon. So it must be the poly version of carbon. Carbonate. Okay, since you're kind of getting the point of first name, last name, try 6 through 10. Talk to the people around you. They might be helpful, or they might need you.
So what's the CU? The CU, CR2, copper,
All right, come back to me for a moment, and then I'll let you finish. Come back to me. 3, 2, 1. All right, give me a thumbs up on 6. Calcium chromate. Calcium chromate. So we had calcium as the first name. We broke it, and we broke that cation off. You remember, you always incorporated cation, either a single metal or randomly ammonium. Okay. So the rest of that CrO4 is chromate. Now, number 7 for copper. Copper is a what kind of metal? Transition. So we got to be on the same page. You can't just say copper, you have to say copper Roman numeral. Now, how would one know that this is copper 2 on this formula?
Because the charges cancel out.
Right, so I'm going to say the charges reduce. So in this case, the copper and the dichromate in the end don't have any kind of charges listed as subscripts. So they had to have been the same charge. So copper had to have been copper something. Dichromate is Cr2O7 2-. And so if that doesn't show up in the end as a subscript, that means this had to have been the same charge. So when we had the 2 2s, we reduced them down to 1 1s. 1 second. So that's why you wrote copper 2 dichromate. Question?
For 6 for me, it says CaC4.
Oh, sorry, I didn't fix it on your paper. That's what 6 is. It says Ca what?
CaC.
Yeah, so I took the 2 out because chromate is CrO4. I think I was mixing those on your guys' paper. Sorry, I haven't fixed all the typos, but there should be maybe one more, but that's it. Okay? All right, so fix all that on 6 for you guys. Thank you. All right, on 8, first name is sodium because sodium is the obvious cation there. ClO2 has a name. It's not chlorate. It's chlorite. Very good. And then again, for the transition metal of iron, and then we have next to it who? Carbonate, and then what's carbonate's charge? 2- because you've got your polyatomic ion list in front of you. So iron, you didn't know the charge, but you had to figure it out. The way you figured it out is by looking at carbonate. Carbonate has a 2- charge, but you'll notice in the end there's no extra subscripts. It's just whatever chromate is. So then they had to be the same. Therefore, it was a 2+. So you write iron 2 carbonate. All right, raise your hand. Tell me with number 10. What's that name? Get me started. Iron 2. How do you know 2? Outside of this guy, right? So that 2 really belongs to iron. So that's iron 2, what? Phosphate. And that 3 came from who? Phosphate's charge. Right, so I'm like uncrisscrossing to verify the charges are right. All right, next one. Nickel what? 2 fluoride, because that is a transition metal. You have to have a Roman numeral. Next one. Say again. Strontium carbide. So first name, last name. That C is just carbon. Carbide is how you would name that. 13. Aluminum. Phosphate. Phosphide. Good, because that's coming straight from the periodic table. Ides are straight from PCOE. Next one. Aluminum phosphate. Good. And if you need to put parentheses around that to help you see phosphate, that's the value putting that there. Will the rest of you guys go grab your laptops for me? We're going to get started on PS9, and then we're going to take a break because I'm going to show you covalent, and then we'll jump back in. Okay? So open up PS9 for me. Excuse me?
This computer already uses
PS9 is on my website where all the other problem sets are. I don't know what you're talking about with computers, so if I'll come right back there in just a second. Okay. If you printed your PS9, I got you. If you printed your PS9, yes, you might have not needed the computer, but I thought I would at least let you see it if you needed it. So, this is on page, I'm going to page 17. Page 17 on that big, huge document. Alright, so while you're kind of getting settled, I'm going to tell you up front, this is blended. This is not just ionic. There's going to be acids and covalent compounds that are coming up. So do not view the covalents or the acids. And the way you would know if something's an acid is, if it says acid, dead giveaway, and acid, you can see that, don't do that. But what I want you to do is all the ones that are ionic. How would you know if something's covalent? Two nonmetals, okay? So let's start here. You can read right here what to do. If it's binary ionic, it just means there's just a metal and a nonmetal. If it's ternary, it's because it has a polyatomic ion involved. So you're just putting Bi or T on this column here. Okay, so let's see where we are in about 15. Let's see where we are. Corbin, what's up? Okay. Obviously, you can get started because I have it right here for you. Don't wait on the computer if it's a little slow. Try to guess the polyatomic ion before you look at your sheet, if you can. So like if you see a formula, try to think of the, or if you see a name, try to think of the formula first. halfway shut your computer so I can have you back and pull back out the note sheet I have provided you? Oh, I thought you would like my jokes. My jokes. I was planking. Oh, never mind. You guys can't see anything. Okay. I was planking before our school. Guess who this is? Max Planck, right? The guy. The guy. H. Okay. And then I love Mythbusters. Remember, guys, the only difference between screwing around in science is writing something down. Okay, so that's where we're always writing our labs and our purposes and our data and nomenclature. Okay, so find the covalent section on your sheet and look and see what more you get right now. Okay, so I think I gave you some of these on your sheet already. Yes? Have you found the covalent section? There's a little box. Okay, there are a couple that are not there. Okay, so I'm going to have you add those. Now, you're going to love covalent because, guys, it is way, way, way easier than ionic. I'm spending a lot of time on ionic up front because you have to think about charges and crisscrossing and the polyatomic ions. They're a butt kicker. That's going to take us a little bit longer, and most of your problem set is ionic because that's just more challenging. Covalents are a piece of cake. Give me a covalent molecule you already know that you breathe out. Carbon dioxide. Why are you saying di? Because there's two oxygens. Are there charges involved in covalent structures? Why no? They're not what? They're sharing electrons. They're not donating electrons. So they make ions. Yay or nay? No. Okay, so big no charges. Okay, that's a big deal because you're going to be like, oh, let me go look for the charge. Let me crisscross charges. No. Do not do anything with charges. No crisscrossing. You name it as you see it. You write it as it's named. There's no question about how to do this. Mono, prefix mono means 1. Di means 2. Tri means 3. Tetra means 4. Penta means 5. Hexa means 6. Hepta means 7. That's one that most people kind of get weirded out by. Not septa. Hepta. Octa means 8. And then what's 9? Nona means 9. What's 10? Deca means 10. Dodeca? Dodeca means what? 12. Right, dodeca means 12. Okay, so we are not going to overuse prefixes. We will only use prefixes on covalent. So they have to be made up of what to be covalent? Okay, so non-metal, non-metal. That means there's no polyatomics, there's no metals, there's no charges, nada. Okay? You will try to start to use prefixes on everything and we'll slap your hand and say, no, do not use prefixes all the time. You're going to get prefix crazy, but try to be narrow-minded with this. It's very just covalent, okay? So, one word of caution. Anytime you have a certain number, you have to use a prefix. If you have 4 carbons, you have to say tetra. If you have 2 oxygens, you have to say di. If you have 3 of something, you have to say tri. The only time you don't ever say a prefix is if you have 1 of something in the front. So the example you just told me was what? CO2, right? You didn't say monocarbon dioxide, right? You don't say mono in the front. That's the only time you don't say mono, is if there's 1 in the front. So we just call this out as carbon, and then we say dioxide. Okay, so obviously carbon dioxide is CO2. What is the next one? CO. This is on your paper, yes? You with me? You writing these down? Okay. So diphosphorus pentoxide. P2, because that's 2 phosphori and 5 O's. O5. Keep going. Dinitrogen monoxide. N2O. There's 2 nitrogens and 1 oxygen. Notice we did say mono on the back side. See, check, check. We can say mono on the back one, but don't say mono on the front one, because it just sounds stupid. It's really why we don't say it. Silicon dioxide.
SiO2.
SiO2. How many SIs do I have? 1. Why? Because there's no prefix out here. No mono, no prefix, just still means 1. Carbon tetrabromide. CBr4. Continue, finish that little section up. If you're already ahead, you want to move over to the naming one, go ahead and do that. right, finish those up with me. Sulfur dioxide. Chant. Let's go. SO2. Phosphorus pentabromide. PBr5. Iodine trichloride. ICL3. Nitrogen triiodide. Ni3. Dinitrogen trioxide. Into O3. Next, that's our formulas to names now, right? Formulas to names. Here we go. Number 1. This is on the same sheet you're working with, okay? 2 nitrogens, 4 oxygens. Go. Okay, dinitrogen tetra. We try not to put and O, so it's just tetroxide. It's totally okay if you misspell it. I'm not big on that. Just trying to make sure you know how to do chemistry. Okay. SO3. Sulfur trioxide. Okay. Complete the rest of those if you're not there. Notice we didn't put monosulfur because it sounds stupid. Okay. Now, if you're done, and you're just like, all right, I'm big chilling here, go ahead and go back to your pod set because you obviously can help me down here. You can check yourself with your brush. I want you to think about them as you go.